Hello, everyone, and welcome to Industrial Ethernet Week 3. This is such an exciting event for us. It's our third annual event, and we've seen the number of participants and registrants grow each year over year. So we're so excited to see the growth of this week, and then also just the level of interest. We've also taken your feedback from previous sessions and tried to incorporate it here. So we're excited to come this year and talk about industrial Ethernet. It's so fun to have players across all of the ecosystem be in this event with us together, from suppliers and customers and partners, even outside consultants and vendors are all going to be participating in this week. So what do we have in front of us? We are going to spend the next few days to talk about industrial Ethernet and get into some of the nitty-gritty for how industrial Ethernet is going to impact our future. Today, we're going to spend almost the entire day on sustainability. And I know sustainability is a big word for a lot of us, and we all hear it. But what does it mean? How is it defined? And what can we do to impact our products and our ecosystem from a sustainability perspective? It is interesting to see how much of our sustainability, all much as the amount of our carbon emissions are actually generated, not from inside our four walls, but outside. And there's a lot we can be doing to impact that. Also, on the sustainability front, what are some of the problems that we're facing when it comes to design? And so we're going to have two panel discussions on some of the problems that are created and what are ways that we see solutions coming about to solve this as well. Tomorrow, we're going to be talking about simplification and ease of installation. This is all about, if you can picture the amount of data that we're going to continue to consume for the next year, 2, 3, 4, 5, 10, 20 years, I think it's pretty clear that this rate of growth is going to be exponential. And the amount of sensors and cameras and processing power that's all going to be consuming data is going to grow. And so our ability to be able to get customers up and running faster, being able to order parts faster, being able to get everything assembled faster and into use faster is going to be pretty critical for success. So we have a full day dedicated towards ease of installation and simplification of design. And then lastly, on Thursday, we're going to be covering innovation. What are some of the problems that we continue to see that will need to be solved? Artificial intelligence is by sure the biggest driver that we see. I think we've probably all been surprised, maybe even over the last 12 months, on how quickly the pace of artificial intelligence is impacting us and our future. And so what are going to be the needs from our technology in solving this problem? And so we'll be talking about the upcoming trends, some of which you may have heard of, and some of which you may have not when it comes to innovation. So we're excited to share that as well. In terms of format, we're doing this on a Zoom call. And as much as this comes off as a presentation, we love to get questions from you, from the audience. And so we would like for you to be able to participate in this event by typing in questions in the chat. We do have a strict timeline that we're going to be following here, but as time allows, we'd love to be able to answer any questions you have as they come up during a presentation or in a panel discussion. And so if you would type your questions in the chat, and we will relay them here and answer them as time allows. And then also, we will be transitioning between events to set up different panel discussions. So we'll take slight pauses in between discussions so we can get set up. So just to give you a sense for how the format works for today and the next couple of days. Okay, well, with that, I think we can go ahead and jump in. I'm going to be talking to you first a little bit about sustainability as a strategic differentiator. My name is Lucas Knapp. I lead our product and market development teams here in HARTING Americas. And sustainability has been a big topic for a lot of companies. I have to be honest, when I first got into the sustainability topic, it felt mostly like people like to say these big words and put a lot of things on the internet about how great their companies were. when it comes to sustainability. But what I've been impressed with is what companies have really been doing to drive sustainability and having, specifically on a carbon footprint side of things, a much better footprint. And so I want to talk a little bit about what is sustainability and how it could be a strategic differentiator. So for the last, 100 years, we've been through this industrial revolution and longer, you could argue that the basis of a transaction with a customer was really based on these four things: quality of your products, the price that the customer is going to pay, and the lead time that they are going to get that product. Over and over and over, you could emphasize more on quality, you could emphasize more on price, you could emphasize more on lead time, or perhaps a fourth one, just relationship. Like you're the one that has a relationship with a customer, and so you're the one that's going to be preferred. And this has played out over and over and over, and you can see these four attributes being played over in every transaction that has gone on in the history of our industrial revolution, if you will. But there seems to be a fifth one emerging, and we have seen it play a bigger part in the last couple of years. And as we look into the future, we talk to our customers and our end users. Having sustainability be a fifth element of the key purchase criteria seems to be an emerging item and one that will differentiate you in the future. We are having customers talk to us about, do you know what your carbon footprint actually is, or what are your sustainability goals? And we have started to see some of this filter into the purchase decision criteria from our customers, and surely for yours as well. So what is sustainability, and how can we impact this? Let's just get into it a little bit. Okay, what is sustainability? It's been defined in three different categories. One is inside your four walls, which are classified as Scope 1 and Scope 2. And I'll go into this in a little bit. And then there's outside of your four walls, which is Scope 3. Okay, so we'll go into what Scope 1, 2, and 3 are if you are not familiar with that. And then also, for most of today, we're going to be talking about the sustainability within your product design and your product carbon footprint as well. And so today's panelists, after I'm finished, will be covering this topic. Okay, so Scope 1 and 2. What is this exactly? Okay, so Scope 1, it all has to do with your direct company asset usage, if you will. What is the emissions? So let's talk about carbon emissions specifically. What are the amount of emissions that are created from the products that you're creating inside your four walls and what you're doing? And Scope 2 is the energy that you're using, the quality of the energy that you're using to conduct those processes. So let's say you have an injection molding machine. Well, certainly that injection molding machine is going to emit emissions as it's in use. And then it's also going to consume electricity as it's in use. So those two things would be Scope 1 and Scope 2. So the quality of the energy that you purchase also determines how much CO2 emissions you're using. So imagine if you're using the energy off the grid, then whatever source of the energy from the grid is that you're getting is the quality of the energy. And of course, if you're one of those companies now that's using either wind energy or solar energy on site as a source for your electricity, that improves your CO2 emissions that you're using on the Scope 2 front. Hopefully this is all kind of starting to make some sense. So this is, in many people's minds, the most important area to focus their sustainability efforts. So as a company, you get together and say, okay, what can we do to improve our footprint? And generally, people look at Scope 1 and Scope 2 emissions. How can we improve our processes? Should we upgrade, as you can see on the slide, should we upgrade our fleet of cars to electric vehicles, for example? Should we put solar panels on the roof or maybe a windmill outside, as you can see in many places excuse me, let's say in Germany, you see it very often. And these are all important things, very much so. We were working with a customer in the semiconductor space they use a very specific gas to conduct a very specific process within the semiconductor manufacturing process. And they realized how harmful this gas was to the environment, scope 1. And so what they're designing now is a new gas that's more environmentally neutral. And so they are working very hard on their scope 1 emissions to create a product and a process to be more beneficial to the environment. These are great things. What is surprising to most people, and it was surprising to me when I learned this, was that the entirety of scope 1 and scope 2 emissions amounts to about 3% of the total emissions created from a manufacturing process to finally get goods from the source all the way to the customer. And there are different estimates out there. This one comes from the World Economic Forum and also from customers that we've talked to directly on their own estimates. And so while you can focus all of your energy, or a lot of energy, on scope 1 and scope 2 emissions, which is still the right thing to do and what your suppliers are doing, what is also of importance is scope 3. Let's just talk a little bit about scope 3 and what that means. Again, about the remaining 97% of emissions created by a supply chain come outside of your four walls. So what does this mean? This is all around what your, basically two things, what your suppliers are using to, in terms of their emissions, and then also the supply chain, getting products from the source all the way to the customer and the amount of emissions created throughout that supply chain. It's an incredible amount of emissions created just from your supply chain. So when you're thinking about, okay, how could we differentiate ourselves from our competition in terms of sustainability, having a focus not only on your own internal emissions, but your supply chain is going to have a big improvement. My guess is that maybe a third of you, the companies that you work for, have started to actually calculate this on your own. And the other 2/3 of you are saying, we know what happens inside of our four walls, but we don't actually know what happens in our supply chain. And I'll tell you that if you are one of the first ones to do this, you will have an advantage. We're seeing it ourselves, and I know if we're seeing it, you'll be seeing it as well. Okay, let's just go through an example here. I want to bring this home on a very, very simple example. Imagine you're making a cable with and adding two connectors on the end. You just have a simple cable assembly beginning to end. If you were to run this process, if you were just wanted to build this cable assembly, you're gonna the foundational element here is copper, I think we all know. So let's say we source copper from Escondida, Chile, from a mine that you can imagine would be the largest copper mine still in the world. We ship this product to China where it gets processed. We add on two connectors on the end, maybe do some overmolding, and now we have the final product. We test it, and then we ship it back, let's say, to a customer in Northern California. If we ship this by boat, this is roughly a little over 80,000 pounds of carbon emissions. What does that mean? Is that a lot or a little? Well, let's just see how it compares to the rest. Okay, if we were to take this is a very simple example, of course, right? You can imagine all of the other products that are needed for industrial Ethernet, like the magnetics, or like the plastic parts, or the connectors themselves. All of these parts, if you start to draw these arrows from where the source is to where the manufacturing is to where the distribution is to where it will finally be consumed, ends up being lots of arrows on the page. And what's surprising is the amount of product that we're shipping over and over and over and over. So this is just the most simple example for demonstration purposes. Let's say we were to build that same harness and we were to source the copper from a mine in Arizona. And then we ship that to Mexico where we can actually build the cable, we can build the connector, do the assembly, and we ship it to that same customer in Northern California, all by truck. It's about 11,000 pounds of carbon emissions. It's an incredible reduction in just the supply, just by moving around the supply chain from where we're sourcing the products all the way to where we're consuming it. And you can see that, again, you can imagine if we added all the other arrows on the chart and all the other carbon emissions created from all the other components and the plastics and what's not, everything else to create this cable assembly. The magnitude at which you can impact your footprint from a sustainability perspective is significant, just by localizing your supply chain. Okay, so again, simple example about if we ship by boat, we use about 112,000 pounds of carbon emissions. When you need that product really bad and we need to rush ship, we're not in that environment right now, but you can imagine 2 years ago, we were very much in this environment where we needed products very quick. Air shipment was one of those things that we did quite often. And probably in 6-9 months or so, we're going to be in an environment again where the demand will be picking up, and this will be a desire, right, to ship through air. This same product, only one product, one route from Chile to China and to Northern California, about 985,000 pounds of carbon emissions. For reference, this is just mind-boggling. For reference, if you had 73,000 cars on the road in the USA that drove 15,000 miles on average per year, that's about the same as 985,000 pounds of carbon emissions. I mean, it's just incredible, the amount that we're spending in carbon emissions to ship products from around the world. And our ability to localize the supply chain, one of the many elements to impact Scope 3, would allow us to have something more like 11,000 pounds of CO2. So again, simple example, but multiply this across all the products that you're purchasing, all of the sourced components, and the amount becomes significant. So I want to go back to the first chart I showed: relationship, quality, price, lead time. These will all continue to be at the top of everyone's mind when it comes to selling your products to your customers. But it looks like sustainability will be a new one, and your ability to quantify within your, again, within your four walls, but also among your supply chain, what's happening from a carbon emission standpoint, it will be a differentiator in the future and can give you an advantage over your competition. So with that, the last thing I wanted to point out here is the lead time. So imagine if you're shipping product on boat to and from countries, on average, about 52 days, if things are running well, to get product in and out. So the amount of inventory that is just being carried on a boat to and from, in between all of these processing steps, is significant. So not only are we, in general, if we have a wildly complex, wildly global supply chain, not only are we emitting all of these emissions just in the supply chain, but we're also overproducing. We have lots of inventory just being carried on a boat and sitting in supply houses and distribution centers. About 52 days. Obviously, if you air freight, you can get something very quick, let's say 40 hours. And then in terms of shipment, you also reduce your lead times in general from localizing a supply chain. The point here is, in general, the benefits of having a localized supply chain not only come from the carbon emissions you create from that supply chain, but also the costs and the lead time as well. So these do actually tie together quite well, and understanding them is the first place to go. So with that, I've covered my section. I'm looking over here at questions here. I haven't seen any questions pop in on the chat. Or any questions come through? Team? Okay, great. Well, thank you so much. We're going to take a 3-minute pause here to set up for the next panelist, but thank you so much for your time and energy.
Good morning, everyone, and welcome to the first panel of Industrial Ethernet Week here at HARTING. We're excited to talk to you today about the intersection between industrial design and sustainability goals. There are quite a few challenges facing manufacturers like HARTING and those of you on the phone, so we're excited to dig into those today with our panel. I'd like to start with introductions. My name is Casey Spitz. I'm responsible for development and innovation here at HARTING's Americas.
Hello, thanks everyone for attending. I'm Vivek. I'm the head of our innovation group in Cambridge, Massachusetts. Glad you're all here.
Hi, I'm Michael Prince. I'm president of Beyond Design, a product development firm located in Chicago. Thank you for inviting me.
Hello, I'm Noah Young. I'm an industrial designer at Beyond Design with a background in design for sustainability.
Excellent. Our primary goal for today is to talk about, as I mentioned, the intersection between sustainability and industrial design. And before we jump into that, I think it's important to discuss what are the challenges that are facing manufacturers today, and then we'll dig into some of those one by one. The first challenge that we're going to talk about in just a few minutes is really how to manage all of lifecycle management through the lens of sustainability. You can't just talk about sustainability after a product has been designed. So we'll dig into that in just a few minutes. The second topic is really the newness of ESG and sustainability for major manufacturers. How are companies handling that in their policies? How are individual employees handling that even at the design level? And then finally, we will talk about the elephant in the room, cost. How is that integrated into sustainability, and how can us as manufacturers help our consumers bear that cost? So to dive in, we'd really like to start talking about the challenges of design and industrial design for sustainability. Noah, I'd like to start with you today. Can you speak to those challenges and how employers and how manufacturers can handle them?
Mm-hmm. Yeah, so something that we find at Beyond Design as a design consultancy is that a lot of times the companies that we work with want to account for sustainability at the end of the process, but in reality, sustainability has to be accounted for from the design and engineering from there on, and every step in between. So the sooner that you can have that plan in mind for how this is going to be a sustainable product, the more successful and the more real world impact you'll be able to make in the future.
Perfect. I think we have a visual that we can share that shows the life cycle process. Any steps that you'd like to highlight in this process?
So yeah, I mean, it's a very simplified version of the process. You know, there should be a lot more loop-de-loops here in terms of going back and forth, but you know, we're coming from the perspective of that design and engineering, and that's really where this all begins. But every step you see here on this graphic is somewhere that sustainable practices can be implemented. And specifically towards the end, something that we always emphasize is the end of life education. That's something that doesn't get accounted for almost ever until it gets to the final resting place. And by that time, it's too late.
Really great points. Michael, anything you'd like to add here?
So it's really important from our perspective on the design side that we understand where the product is going to lie, whether it's a professional product or whether it's a consumer product, and looking at, from the design standpoint, the materials that are going to go into this, the sustainability that will affect, but also the longevity of the product. Sometimes we have to use virgin materials, while in other cases we're trying to use more composites that are recycled or regrind to actually reuse the materials, but it really depends upon the application. So we work closely with our clients to really understand what the applications are so we can choose the right materials.
Perfect. And I know that we will take some time to dig into the material side, but I do also see this IIoT shape right here in the middle. And this is huge for HARTING. We spend a lot of time thinking about IIoT. Vivek, could you speak a little bit to how the emergence and the huge expansion of IoT in the production floor intersects with sustainability?
Yeah, no, absolutely. It's a very critical part of being able to really understand and measure and control emissions throughout the entire product life cycle in manufacturing. So, for example, you know, Lucas brought up an excellent point in his introduction that 97% of emissions are really out there in the supply chain. That starts all the way back at, you know, raw materials through preliminary processing, through manufacturing, warehousing, distribution, and at each point, the industrial Ethernet will enable us to effectively measure, because we cannot control that which we are not measuring. I mean, that's like a fundamental axiom. So the power of the industrial Ethernet is really the ability to measure at the raw material stage. For example, a lot of companies now are looking at electrification, even down at mining equipment. And so you're able to get a really good understanding of what's happening at the raw material source. Manufacturing has traditionally been the home of IIoT and Industry 4.0. That's where it grew up, essentially. The fourth industrial revolution is Industry 4.0. So in manufacturing, people have already been utilizing this. But for example, now you could use energy as a variable in production. So if I can delay something a week, I could maybe shut down 3 or 4 milling machines here, a couple of lathes here. All of that adds up cumulatively, when you look at the overall greenhouse gas emissions. Warehousing is a really, really good point. And here again, Lucas had brought up the fact, between shipping via boat, air freight, truck, they all have their consequences. And here again, what we've seen in warehousing is a tremendous expansion in the use of IIoT tools to understand exactly what's going on, where the products are, where they're going, how much energy you're consuming within the warehouse. That's become a really big thing. Information is part of manufacturing. Manufacturing consists of materials, methods, and information coming together to make a product. And here again, the advent of data collection and AI and sensors is driving, the growth in data centers, but data centers obviously consume a lot of energy in and of themselves. So, IIoT is a very powerful tool for understanding where energy and resources are flowing within the entire product ecosystem, and eventually to be able to control these and, really systematically bring down emissions.
Excellent viewpoint. Michael, I know at Beyond Design, you work with an incredibly diverse set of customers. Can you talk about how they're handling IoT and how the design is contributing to that with a sustainable view?
A lot of our customers, it'll vary from a consumer product to industrial product. So it really depends upon the customer and the importance, and comes a lot down to the cost. More of our customers are starting to look at alternatives rather than just automatically going to China. They're trying to bring it back locally. And they are understanding that by having it locally, they have better control. While their cost might be slightly higher, they have less on the inventory, so they have less risk. So all of these factors that we're talking about come into play, and that's causing an effect on where manufacturing is happening, as well as how it's being shipped, and ultimately where is it being stored. So for our standpoint, it's affecting every aspect of that design, because we need to make sure that it's going to fit within that system.
Perfect, thank you. So we'd like to talk about what I mentioned before, the elephant in the room about sustainability, cost. A big aspect of what we think about is, our customers have a need for sustainability. How can we build in that need in a cost-neutral way? Sometimes that's possible, sometimes that's not possible. So what I'd love to talk about is in that spectrum of what the market will bear versus the manufacturer needs to cover, what can designers and manufacturers do to address the need to drive sustainability while keeping the cost down? And I'd like to start with the Beyond Design team on this one.
From our perspective, we're the consultant, so we have certain amount of suggestions and education. I think it all comes down to education, but ultimately we don't have that final say on where it's going to be manufactured and assembled ultimately. So what we try and do is educate our customers through participating in events like this, so that we can let them know that there are alternatives. The alternatives aren't necessarily about changing of materials. We like it to start there, but sometimes it's really about the education and designing for disassembly, or designing so that we can remove certain parts out of the product, such as a lithium-ion battery, before it gets into a landfill. So we're looking at design and trying to educate our customers on how they can do a better job to be part of the system.
Yeah, I would just say, like, one example of things that we've actually in real world talked to clients about before and tried to push them to implement is, for larger companies, using recycled materials can come with hazards. The quality of the material doesn't have the same characteristics that you need. So if you are a larger company and you need that control over your material, there is the opportunity to not only be more sustainable, but also save costs by possibly implementing an in-house recycling program. So you're keeping your your product stream in-house, you're maintaining that quality, there's nothing else getting in there. again, this has possibly a higher upfront cost, but in the future, you're not having to get virgin materials often, and it will be cheaper, in the near future.
Vivek, can you share your perspective as well?
Yeah, I mean, one of the things that we're seeing, which is a very positive trend, is the ubiquitous use of digital design tools, simulations, and virtualization, and the whole concept of digital twin. Actually starting all the way back at the design phase, through the manufacturing. This allows us to, I think, really reduce the overall amount of effort to optimize, different products, and also to, really powerfully leverage the use of simulation tools that can, reduce sort of the design life cycle, but also, take into account all these other optimization factors, such as material usage, energy, design for total, life cycle. How do you, what's going to happen at end of life, for this product? So that's one of the very powerful aspects, I believe, of, Industry 4.0 is the entire concept of the virtualization shell, starting all the way back at the design process through manufacturing and ultimately through end of life, is definitely going to help, companies to meet their sustainability goals. And here again, the industrial Ethernet plays a key role because the industrial Ethernet allows you to connect the digital world to the real world and to be able to see, how these two correlate. So it's a very important aspect.
And we hear a lot about digital twins, virtualization. Can you paint a picture for the audience, the difference and maybe the intersection between digital twin and simulation?
Yeah, so it's not just a CAD model. It's much more than that. You can think of it as basically also embodying all the different aspects of the physical object. So it's really the handshake where the cyber and physical worlds meet. And why is this useful? It's useful because it can drive, simulation. So, for example, very recently, one of the big airports in the world at London Heathrow, they implemented a new baggage handling system, and many of our customers are in that area of baggage handling and logistics. The entire process was simulated, to begin with, and that was a tremendous savings in terms of cost, installation, just time, to be able to get this up on time. And so we're seeing more and more very powerful implementations of digital twin with simulation, and with optimization tools, increasingly AI-driven optimization tools, which are, enable basically the product to be commissioned in a much faster time frame, and also at lower, overall energy costs.
Perfect. And what I'd like to ask the audience to do, please drop in any questions that you may have. We have moderators here that are standing by. You have the perfect segue to the first question we received, which is about AI. So besides sustainability, AI is probably the most talked about thing on LinkedIn right now. And Vivek, I'd love to kick this over to you. Is AI hurting sustainability? Is it helping sustainability? Do people know what AI is? Can you speak to this?
Yeah, so it's a really good question. So first of all, nothing is free. AI costs energy. And when you look at these gigantic models, these so-called deep learning models that are in the cloud, they consume immense amounts of energy. So on the one hand, AI is a powerful tool in helping people meet ESG goals. On the other hand, it's also driving a lot of greenhouse gas emissions in and of itself, due to the fact that it really does take a lot of power to run these massive models. One thing that the industrial Ethernet could enable is a very powerful concept called edge computing and edge AI. So instead of having the big AI in the sky, imagine if you could have many distributed models, down on the shop floor, in the warehouse, at the customer site. And what you can do is pre-process a lot of this data, this torrent of data that, again, Lucas mentioned, that we're facing an exponential increase, in data. So how do we manage this effectively? Not all of that has to go to the cloud. What if you could very effectively pre-process a lot of it, derive some insights right at the machine tool, right at the manufacturing site, right at the warehouse, and then utilize AI at a cloud level to basically disseminate these insights across an enterprise? And so I think the future in AI, at least for the industrial environment, is going to be a combination of edge computing, localized data reduction, localized insights combined with the cloud level. And this will result in an overall a more energy efficient implementation of AI, but it'll also give customers more control over their data and their insights. And here again, I feel the industrial Ethernet is very critical to enabling this because it's basically the data highway, the data backbone that's going to enable all of this to happen in the future.
Excellent, thank you. We have one more question in from the audience, and I think it's based off of the discussion that Noah and Michael were having earlier about alternative materials. So can you talk a little bit about where you see some of the experimentation happening with alternative materials? Is it more on the consumer side? Has it hit mainstream B2B applications yet? And where are we in that technology adoption curve?
Yeah. I think where we see, I mean, first and foremost, where we see a lot of experimentation with sustainable materials is in packaging. It's, you know, it's the shortest step to go in terms of, you know, changing your materials up. So, you know, going from a plastic clamshell to maybe compressed paper pulp, the cost isn't that crazy of a jump, and, you know, the longevity of that product for sitting on a shelf is going to be roughly the same, but you have that recyclability aspect. We are starting to see companies more and more, you know, willing to take risks when it comes to consumer products. A lot of, you know, home products, home goods, things like that, that don't have, again, that real materialistic need to be, you know, super durable or meet crazy standards, because, you know, it still is, we're still experimenting with these, and there are still a lot of great alternatives out there that meet those needs. They're just, you know, a little bit tougher to make, a little bit more expensive. You know, it's in its infancy.
Just kind of to add to that, one of the customers that we're working with, it has to do with foam and paper. And so the foam that they're using is not recyclable, at least from the standpoint from the recycling plants. There's no value to it. There's not enough monetary to come back to them for recycling that material. And so if we were to change that material to where they could accept it, the question then comes, well, we've been trained not to accept it, so they need education so that the change is now going to be able to fit right in and streamline with their system. Because of that, it comes back to education about these new materials.
And you're seeing that both on the design side as well as the consumer side, the education?
Yes, especially on the manufacturing side, because they're so used to using, you know, a typical ABS or a polypropylene, and to start looking at alternative materials, their questions are really coming back to quality. And so someone's got to take that faith and actually do that testing to change the materials to then push it forward. As more and more companies start to change the use of the materials, going from the bad materials to the good materials, the prices will come down and it will be more affordable and it will start to change. But it's just now starting to happen where customers are asking for what those alternatives could be.
And just to add one more brief comment on that, just on the as product developers and designers, there is the aspect of sometimes what seems to be a sustainable material isn't necessarily the most sustainable option. It might be great in one aspect. It might, you know, be the best for it's not a great term, but greenwashing, you know, it makes your product look really good. But again, what Michael's saying is like those end of life processes, if there's not infrastructure there yet, that material is just as good as, you know, a traditional ABS, because it's going to end up in the landfill anyway. So being smart with your sustainable choices.
Perfect. Thank you very much. We have a great question that's come in from the audience. So prototyping and testing were on the lifecycle loop that we showed earlier, and maybe we can pull up that visual once again. Can our panelists comment on how prototyping and testing changes when you're designing for a future sustainable environment? Maybe Noah, I can start with you.
Yeah. So I think something that we're seeing a lot, and something that Vivek touched on, was the kind of like the digitization of prototyping. So we, you know, right now as a product consultancy, we do a lot of physical prototyping with 3D printing, you know, getting parts, you know, CNC'd, manufactured for small scale, which in that aspect, you know, the carbon footprint isn't huge, but when you get to the engineering side and you need to do more rigorous testing and getting production models, I think the digital twin and using the various AI programs to, you know, improve on that rather than physical prototyping is kind of the future.
I would also add to that, we've been into 3D printing for probably about 2 decades, decade and a half. And what it's done is it's sped up our process, and we go from a concept to an idea. We take that sketch, we put that into CAD. We're then able to 3D print that, and within a couple of hours, we're able to then physically evaluate and test that. And if you compare that to the older ways, we would have to take that, do detailed drawings, send the drawings out, get quotes on them, then be able to get the parts back, then do the evaluation and start that process all over again. So from our customer standpoint, we're able to work extremely fast and prove out and prove what is going to work and what's not going to work so that we can keep moving forward on the program. So we haven't actually added up to figure out what that reduction is in our digital footprint. But I can tell you the time that we've saved has probably been tenfold just because of going digital.
Excellent. We have one last question from the audience. After we answer this question, we'll take a short break and then we'll come back for session 2 of this discussion. So Vivek, this question seems perfect for you. The question says, the GPU chips for AI reduce the number of CPUs in the backend system, which of course has a positive impact on the environmental footprint for AI applications. Can you imagine replacing copper with optical I/O to enhance data performance in the communication level?
So, I mean, this is a really good question. So there are multiple aspects to this. First of all is the computational platform. Secondly is the communication protocol. So I'll address these two separately. What we're also seeing is a potential blurring of the lines between hardware and software. So you're having chip designs come out right now that are specifically designed for AI and that are very computationally efficient, energy efficient. But there's also a software trend called, TinyML, compressed models, where basically I can take a gigantic model that may be running in the cloud, I can shrink it down to something that could even run on a 32-bit microcontroller. So I may not even necessarily need a GPU or a CPU. And when we look at all these different hardware options, especially in light of edge computing and cloud computing taken as a symbiotic system, as it were, that's where you could really, realize some savings. So let me get very specific. Say, for example, I'm looking just at 3-phase power. So I'm really measuring only 6, variables, 3 voltages and 3 currents. I could design a very efficient AI to basically analyze that, look for faults, even do things like predictive maintenance, based on the power consumption of that specific machine. And here again, industrial Ethernet is going to be a key to getting that data in and out, of the production environment. Now, to address the the communication protocol, typically, we always think of fiber optic in terms of long distances, Ethernet access, things of that nature. Increasingly, the sensor load in manufacturing and in supply chain and warehouses is getting so big that we may actually see fiber optic, for example, in the next generation mobile robots, AMRs, in warehouses that are collecting tremendous amounts of information. Imagine an autonomous mobile robot that has to basically navigate itself and avoid collisions with people, equipment, other robots, to get things in and out of a warehouse. That level of computation requires a lot of sensors. And so we're even seeing instances in which fiber optic may be actually very valuable as a connectivity tool in the industrial environment. And so there also arises this need for sort of a media conversion, going from copper to fiber. And that's very vital. And so these are all, areas in connectivity which are vitally important, as we look to the future. And, I believe industrial Ethernet has a very big role to play in that.
I knew that would be the perfect question for you with your background and experience. So we're going to take a 5-minute break. I'm going to leave you with an Industrial Ethernet Week cliffhanger, the first time we've ever done this before. So when we come back in just a few short minutes, the question that we'll start with from the audience: what are some practices your average consumer can implement to contribute to a more sustainable product lifecycle? We'll be right back. Good morning, everyone, and welcome back to our panel on sustainability. We're here today celebrating Industrial Ethernet Week with HARTING and Beyond Design, talking about the intersection of sustainability and design. I'm Casey Spitz, responsible for development and innovation here in HARTING Americas.
Vivek Dave, the head of the Innovation Hub in Cambridge.
Michael Prince, president of Beyond Design.
Noah Young, industrial designer at Beyond Design.
Thank you for those of you who are rejoining. We are here for the second part of our panel, and we'd like to start with a question from the audience from the first part. I think this is going to be a really interesting discussion for us here. What are some of the practices your average consumer can implement to contribute to a more sustainable product life cycle? I'd like to start with Beyond Design, and then we'll switch it over to HARTING.
It really starts with the materials and separation of materials, so education. I honestly believe that if at the youth we're able to get the students and to understand what is a polypropylene material, what is an ABS material, how can we separate these materials to go back into the right stream so that they don't end up into landfills. So education is really where I would start with. Noah?
Yeah, I think I mean, there's numerous ways. One of them I would definitely say is just being a conscious consumer, not only in the way of knowing who you're buying from, where the materials or where the product is at least coming from. You know, you can't get that granular with it, but also just being conscious of, and this is controversial to say because we sell products, we try to get more products out there, but do you need a new toaster, or is your current toaster fine for a few more years? And not just buying without, taking, a thought about it. Really stepping back to make sure that there's a need before you contribute more.
Mhm.
And I'd like to build off of that because we see in the consumer space the expansion of fast fashion, right?
Mhm.
So products that are meant to be used once. They talk a lot about clothing, but I'm curious if you see the same thing in physical product. Is there a fast fashion that's happening in the B2B space? And if so, how can we avoid it?
Fast fashion, it's an interesting term. From a product standpoint, we're trying to push our clients to longevity.
Mhm.
If we could get the products to last longer, be made out of better materials, change the life cycle of the product, that's really where we're trying to push. To have customization, it's possible. It really depends upon the product that we're developing and the types of customization that they're looking for. So, for instance, in the fashion, just being able to change the fabrics is relatively easy. If we're going to be designing a toaster, we're going to need materials that are going to perform. So, color finish materials are things that we can play with relatively easily
Mhm.
to accommodate customers and changes with lifestyles as well as trends that are happening.
And on that fast fashion example, for us coming as designers, a reason why fast fashion has become such a thing is because styles are changing constantly and speeding up and speeding up. So everyone wants what's new immediately. So a way that we can, contribute to having a heritage product, a product with, increased longevity, is incorporating as timeless of designs or as customizable, adaptable as designs as possible, so that it doesn't look dated immediately and it doesn't stick out like a sore thumb, amongst your other beautiful products that you own.
Mhm. And Vivek, maybe you can speak a little bit to this. I know that connectors may not be the most fashionable product, but can you talk about how industrial Ethernet can be used for future proofing on, let's say, a production floor?
Yeah, so definitely in terms of the data as we talked about, data in terms of energy consumption, in terms of quality, in terms of yield, in terms of uptime, but also from a connectivity perspective. I think one aspect which is often overlooked is really the requirements, design requirements. Because, so, for example, if we have a connector that could be used for any possible anticipated, end use application, it has to go through a lot of testing, a lot of qualification. What if a customer were to say, you know what, I don't care about railway flammability or whether it's going to work in a aerospace environment. I'm just going to put it into this industrial application. I only need this IP rating, this power rating, so on and so forth. So, bespoke requirements can actually play a big role in sort of reducing, the overall cost it takes, both in terms of money as well as energy, to bring a new product, to market. So that, in combination with very effectively utilizing, process data across the enterprise, starting all the way at design, through production and into logistics and distribution, I think is a very key strategy. And here, industrial Ethernet is sort of the backbone, in being able to get all this data, process it effectively, and leverage some of the edge to cloud AI strategies that we talked about previously.
What it comes back to me is what we always heard when we were children: reduce, reuse, recycle, right? And I know Lucas in his earlier presentations shared some of the terminology that's being used now, but those 3 R's have always stuck with me. So can you speak to how industrial Ethernet specifically can help with reduction? Are there technology changes that are reducing material needs, anything like that?
Yeah, no, for sure. So, for example, we talked about the example in production where if I were able to incorporate energy as a planning variable, so if this product is not needed immediately, do I necessarily need to produce that in the same batch? Okay, it may be more convenient to do that, but if I had energy is a variable in my production planning, I could maybe push that out a week here, pull that in a week here, and sort of optimize, the overall energy utilization, within the production plant. So that's one very clear example. I would say 80% of the cost and the energy impact and the embodied carbon is set at design time. And so that's why the design decisions we make are so critical, right up front, because there's only so much you can do after the fact, to try to recover and try to reduce that greenhouse gas footprint. So I think it's a combination between, the decisions we make at design time and then very effectively optimizing across these different, verticals, which are often, stovepiped or chimneyed, typically manufacturing and logistics, they may or may not talk to one another. I think now we have to. If we really want to be effective in reducing this overall, greenhouse gas emission footprint across the enterprise, we have to break down these silos. And here again, industrial Ethernet is a very critical tool to very rapidly exchange information, across many aspects of the enterprise.
Strongly agree.
So continuing on with the reduce, reuse, recycle trend, I'd like to talk a little bit about end of life of product. In some cases that's recycle, in some cases that's not. Noah, earlier you had raised a topic that many manufacturers may not think of the final end state of their product. What do we need to be doing on the education side, to Michael's point earlier, and how do we change that story going forward?
Yeah. So I mean, on the reduce, reuse, recycle, it kind of starts that as a basis. We think of those as like a triad, but it's really a hierarchy. So reduce is number one. That's your main goal when you're starting out, reducing, your emissions, your amount of material used. Reuse is, the secondary resort, and then recycle really should be the last resort, but we've turned to that to be our primary resort. So since we're dealing with that though, a way that designers, I think, and what we've implemented is a way to make sure that you're designing for end of life is just opening those lines of communication like we were just talking about. You can visit your local, MRF facility. You can talk to the people that are actually disposing of your product. We live, in America. We have a unique situation. There's no, strict federal regulations when it comes to recycling, typically, special cases for specific products. But most of it is up to state or even city or local municipality. So really going, if you're a manufacturer, opening up that line of communication with your, disposer, talking to them directly, seeing what your city, what your town does and what those requirements are immediately. And, like I mentioned before, it's doing that at the very beginning of the product development.
We're talking with companies about how they can change their process. One particular one is about spray cans, and they use spray cans by the thousands on a daily basis. And so how do you properly dispose of them? And so we're always looking at new ways of changing the can or changing that whole process. But in the end, it might not be the solution to change the product, but it's really about how to bring the product back to properly dispose of it. And that comes back to whose responsibility is it? Is it the end users? Is it the company? Or is it going to be the manufacturer? And those discussions are happening. It does come down to cost. But ultimately, I think with government pressure, it's coming back and being put more on the companies themselves and the manufacturers. You see a lot of that happening in Europe, and so the trends that happen in Europe tend to come into the U.S. probably. I mean, it's slow. It's probably like 5 to 10 years that it takes, but it's happening, and people are really starting to consider it. And I would say our customers, they are considering options. They're just moving very slowly at it.
So speaking on that trend, are there specific opportunities that you see for manufacturers to help customers hit their ESG goals? Should we be following the trends of Europe? Are there unique opportunities that are happening here in the States?
We work in the HVAC market quite a bit. And in a case like that, the government is really pushing the manufacturers, which is then pushing the consumers for change in the industry. And this is all to better the environment. So I think that it's the responsibility of the manufacturers to start opening up and educating. I keep talking about education, but that's what opens up the channels of communication, which is what Noah's really pushing. And so if the manufacturers could let the consumers understand why the changes have to happen, there'll be more acceptance. I think it will happen faster, which is what needs to happen.
Perfect. Noah, would you like to add anything?
Yeah, I mean, well, trying to think of how to word it without just repeating what Michael said. Like maybe you have something to add to that.
Well, I mean, let me just change the discussion topic just a little bit and address some of the issues of manufacturing itself. And when we look at, typically today, when you look at manufacturing, especially in high volume production, we're basically optimizing for cost and delivery, right? But you had referenced 3D printing, other technologies which are more localized, produce on demand, on site, where you need it, when you need it. And by actually doing that, you do tend to eliminate a lot of the energy costs associated with transportation, shipping, inventory. But that also requires a mindset change, that you have to look at the total cost of ownership, not just, I want absolutely the cheapest price up front, but what is my life cycle cost? And cost not just in dollars, but in kilograms of CO2. And when you look at that, all of a sudden 3D printing is not necessarily just a prototyping or a low volume production process. It may end up being actually a viable, production process when you look at the total life cycle cost. And so I think part of the challenge, especially in the B2B industrial environment, is getting away from this mindset that everything is purely driven only by, dollars. There's another variable out there called kilograms of CO2. And when we try to optimize for both of these, I think, we could definitely embrace different manufacturing methods that are, more localized, in the region for the region, lower emissions overall, eliminating this complex web of logistics. And quite frankly, that's even more robust and more resilient, because as we saw, unfortunately, in the pandemic, there was sort of a massive breakdown of global and massive disruption of global supply chains. And so I think a lot of people, a lot of companies are now embracing the concept of localization and sort of this not redundancy, but robustness and resilience in the supply chain. So I think, to change the discussion a little bit, some of the ways in which we manufacture things right now, need to be rethought. And that can definitely contribute, I think, to ESG goals. Although it could have an impact on incremental cost, we need to look at the overall cost over the entire enterprise.
And to build off of what you're saying, we feel that very strongly here. In the building that we're sitting in today, we have on-site manufacturing. So to have manufacturing in the Americas in Chicagoland is not something that was really happening 7-10 years ago. It was much more of a just-in-time model coming from low-cost manufacturing locations. So in addition to localizing, we're seeing the reduction in CO2 emissions from shipping. We're also seeing higher customer service levels because of the reduction in shipping time. Can you expand upon that and how it's sustaining or contributing to sustainability goals?
Yeah, no, and absolutely. And I think there's been this myth of low-cost production, because the fact of the matter is we basically pushed the problems to another part of the world where someone else had to deal with it. And the fact of the matter is, that whole thing of low-cost production, they have more relaxed environmental standards. No, that's wrong. China, India, other parts of the world, they're realizing that, hey, we're not the dumping grounds for Western countries. They're actually leading in a lot of ways. When you look at renewable energy, China's definitely putting in massive investments in that regard. And so I think this entire myth of constantly chasing low-cost production around the world is going to end, and that's a good thing, by the way, because now that forces us to consider all these systems level problems that we previously just tried to push off, and I'm talking across industries. This is not, within connectors or industrial products. It's basically all industries. And so I think when you think about it that way, again, this sort of total, life cycle approach really forces you to reconsider, a lot of things about where you're sourcing materials, how you're producing them, and at what scale and what level you're producing them. And I'm very excited, that the industrial Ethernet, implementations here are also going to, I think, assist in that transformation and rethinking of not just manufacturing, but how we really conduct business, globally.
See, I think that Americans have been conditioned to low-cost, disposable. I'll buy a toaster. I expect it to work for a couple of years. I'm going to move. I'm going to throw it away. I'm not going to take it with me. And I'll just buy a new one because it's low cost. And as prices start to go up because costs are just generally going on materials and labor, et cetera, if we as designers can start to design them so they can be fixed or they can be reused in a certain way so that the longevity doubles or triples and people are going to hold on to those products longer, that's an area that we as designers would like to get to. But a lot of it's changing the mindset of Americans, the Walmarts of America. You go in, you expect the lowest price, but you don't expect it to last very long. Change that to where I expect to pay a little bit more, but it's going to last a lot longer. And we see a lot of those trends happening, from Europe, where parts that were typically plastic, maybe they're going to be a die-cast metal. And because of that, it's going to last longer. And because of that, it's going to be quieter. But yes, it's going to be more expensive. So that mindset, as we can change that in American and in the world, that price is not the leading factor in a decision that you're going to make to buy that product.
Yeah.
If there are any toaster manufacturers online, we love your product. Love to put industrial Ethernet on them. Call me afterwards.
But that's actually a good point, though. It's like, how much energy is that toaster really using? And are there ways that I could be more educated and conscious of how I'm using that appliance? It's kind of like brushing your teeth with water. A lot of people will turn the water on, and just while they're brushing their teeth, they'll let that water run. I actually saw in one of the toothpaste, they have a thing really suggesting to shut the water off when you're brushing your teeth. Now, this is a toothpaste company trying to promote that to better the environment. So it goes back to that education that I keep talking about.
Well, not to keep harping on the toaster example, but it is an interesting aspect of a lot of people might, you have an old toaster. It's clearly not as efficient as brand new toaster. You're using more energy per use of that toaster, but that still might not equal the amount of, your carbon footprint of buying a brand new, super efficient toaster that brand new one did before it even hit the shelves. So you keeping that older, less efficient one, it doesn't feel as good. It doesn't make, it uses a little bit more power. But if you are trying purely to reduce your carbon footprint, it might still be the more sustainable option. It's, it's just kind of shifting your thinking.
Absolutely. And I know for many of those that are on the line, you might be working for companies that make, as an example, injection molding machines. This is very much in the supply chain and the process chain of a toaster. So it's about making high quality products that don't need to be disposed of. That's going back to reduce, reuse, recycle. That's the reduce. Absolutely. And that might be even more important to your point than how do you dispose of it at the end of its life. If we can bring up the graphic again, we keep coming back to this life cycle management aspect of it. So we've talked about the early prototyping, we talked about digital twin, we've talked about the disposal at the end, we've talked about IoT in the middle. But what we haven't talked about is how to look at supply chain through this entire life cycle management. What I'm hearing you guys saying as our expert panelists is these can't be done in isolation anymore. So for the Beyond Design team, I'd love to hear if you could share your perspective. Has your customers' views on how they design with supply chain in mind changed over the time that you guys have been in business?
Yes. I'm a little bit older, so I can recall back in the 80s. But in the 80s and 90s, a lot of manufacturing was going overseas to China. Why? Because of low-cost labor. But I think a lot of it was the fact that they were able to get around policies in the US that were to protect the environment. And so we just kind of shifted it over there. Wasn't the right thing to do, but again, going back, Americans wanting a lower cost, that was what happened. The mindset now changing. I think that manufacturing is starting to go a lot to Mexico, which is actually really good because it's closer. So from an emission standpoint, there's a lot less travel. From a timing standpoint, it's a lot better. So as designers, we're really hopeful, encouraged, and excited about that opportunity. The closer we are to the manufacturers, the more we can talk and really figure out ways to improve the design, reduce or change the materials, and keep going forward into quality control.
Perfect, thank you. So we've talked a little bit about some of the trends that are facing designers, but one trend that we feel very strongly at HARTING is miniaturization. And I know we've seen a shift recently where miniaturization has come from our customers as a way to make their products smaller, but now we're actually seeing the connection with sustainability. So a miniaturized control cabinet requires less metal. Vivek, can you speak a little bit to this trend where miniaturization is helping people meet their ESG goals?
Yeah, no, absolutely. It's a very vital trend. And so again, let's pick on the data center market where we're seeing a need for greater and greater power at the rack level. So for example, going from maybe 33 kilowatts at the rack level all the way to 100 kilowatt at the rack level. But you don't necessarily want to increase the size of the connections. And so that puts a really big onus on looking at, for example, high energy density. But let's think about the implications of that. If we could save even 2% of all the energy that's flowing through a connector going into a rack level, based on 2020, data center power consumption, 2%, just looking at 2% of the US data center market, if we could save that energy by having a more efficient, high energy density miniaturized connector, that would have saved 950 million kilowatt hours. So even a very small change can move the needle dramatically. And so we're seeing this across the board in power, in signal, in data. You're right. There's an increasing need for wanting to miniaturize, combine different functionalities, and really sort of shrink the footprint, the physical footprint, but also enable these devices in some cases to become intelligent, active, aware. And that's where the industrial Ethernet piece really is important, because it's not just about how the device is functioning, it's about the data and the information I can get out of the device. And so I personally think it's actually a very exciting time in connectivity, because we're sort of enabling a lot of our customers to reach their goals in terms of miniaturization, higher energy density, higher information density. These two things go together. And so, I think the industrial Ethernet is right there in the mix.
Absolutely. And we're seeing similar trends happening in the rail space as well, where previously weight reductions were considered a cost optimizer. We're now seeing the strong connection between reductions in weight to sustainability goals. Single pair Ethernet is a big contributor to that weight reduction. Could you briefly explain single pair Ethernet for our audience and how it contributes to that weight reduction?
Yeah, sure. So, single pair Ethernet, as the term implies, is a single pair of wires that's able to very effectively get data at large distances. And I think that's one of the key things. Large distances, simple, lighter weight cables, lighter weight connectors, and even reducing 1 kilogram of mass off of a locomotive, off of a rail car, really has a big impact over its 30-year life cycle when you think about the fuel savings that can result in. So there's a constant need, I think, for again, the higher energy density, the higher more information communication, but at a lighter weight, and a smaller form factor. And single pair Ethernet, I think definitely enables that miniaturization. The ability to basically get digital data over much longer distances than conventional Ethernet technology would do.
That's perfect. Thank you. From the Beyond Design team, are you seeing similar requests for weight reduction in designs as a way to reduce material?
Especially products that are coming from overseas. They're trying to fit more products onto the boats, therefore they're going to lower their cost. So a lot of times customers will come to us and they'll start out with what their maximum height is, width and depth for that container that they're going to be designing for shipping the product over. So that starts with our requirements. As far as the overall products, we look a lot about the ergonomics and how someone's going to actually interface with it, how they're going to touch it, in a cable, how they're going to actually install it, how they're going to release it. So we try to make it as small as possible, but again, we're looking at to make sure that the ergonomics are going to be proper and we don't lose sight of that.
I know that's something that you specialize in your design firm, is the ergonomics. So if ergonomics is always king, are you starting to see sustainability creep up on the priority list?
Do you have an answer?
I mean, sustainability is definitely up there, and it can, when you're trying to reduce the amount of material as much as possible on something that's, like, let's say you're doing something that has a handle on it. You don't want to make that, you could probably make that handle like a 1/4 inch thick. You don't want to do that because it doesn't feel great in your hand. So then that comes to the internal design of the unit. So you still have a nicely designed ergonomic exterior housing, but then on the internal engineering of the various ribs and bosses and reducing as much material internally that the consumer does not feel or see is where you can make a difference there.
And that's a good point. And you were mentioning that earlier, that sometimes the requirements that clients will put onto a particular project are so high and so unobtainable that the cost just drives higher and higher and higher. But if you're able to really look at what those requirements should be, then you have a better chance of getting a lower cost and meeting them. And I think that understanding is what's important at the beginning of the process. So for instance, if we're designing, an e-charger, let's say, that wall thickness, are we going to use 0.1 inch? Are we going to use 0.08, 0.07, 0.06? And it comes down to the requirement, which is the drop test. And who determines the drop test? Whether it's an industry or whether it's a company, those are the things that we're trying to design to meet. And we have to challenge, are those the right specs? And that's a way that we can reduce all the emissions.
Are you feeling these pressure on both consumer products and business-to-business products, or one more than the other?
Probably more on the B2B side,
Okay.
even though it should be the opposite. It's just on the consumer side, it's price, price, price,
Yeah.
speed to market. And between those two, usually the last one being the recycling becomes least important. But I would say though, on the packaging side, on consumer, it's changing a lot because of Amazon, right? So when you would go into a retail store, let's call it a CVS store, they would have big plastic that you needed a knife or scissors to cut into to be able to get the product out. It was tamper-proof. Well, the retailers were asking for that kind of packaging to prevent theft. Well, now all of a sudden you've got Amazon, so you don't have that problem. Therefore, the packaging doesn't need to be this big piece of plastic. Therefore, there's a real need to reduce the packaging in a case like that because the needs of that packaging change. And so as designers, we understand that, and we're pushing our clients to really understand that as well, that the retailers are no longer have good reasons for packaging that's not really appropriate for the environment.
So it sounds like in both cases, EV chargers and more consumer products, we're seeing major disruptors coming in and changing the market. Tesla's changing the market for EV chargers, setting expectation. Amazon's changing it for packaging. Any guesses what the next big disruptor will be?
I'm really hoping it's around lithium-ion batteries.
Okay.
More and more products that we design that are consumer electronics have a lithium-ion battery built into it. You can't access it. So when we think about end of life, we're thinking about where is that battery going to reside? And some people say, well, it's really just a small battery. But when you start looking at the number of batteries, the number of products that are out there, I question where is it going, and whose responsibility is it to watch where it goes? And so we're trying to push harder and harder for our customers to think about that and to allow us to really dive in to see if there's a way to remove those bad parts easier, whether it be with screws as opposed to a sonic weld or snaps that can come apart. Again, that starts at the design process.
I definitely experienced that in my home with 3 young children. There's a lot of toys that have non-rechargeable batteries, and it can be a frustrating experience. And to your point about education earlier, very confusing what to do with that product once it's reached its end of life, because you can't simply throw it away. Wonderful. So we have a great question coming in from the audience. I'll let you guys decide who wants to answer this one first. What is the most critical path forward for manufacturers and designers on their journey to sustainability and helping their customers meet the ESG goals? So what do we need to be doing right now with importance?
I come back to education. I hate to keep harping on it, but understanding what ESG is and all the aspects that you can improve your ratings, your level of emissions. You just need to take every precautions to look at it carefully and break it down and say, can we do this better? And if you can do it better, make that push to have it happen. So, from our standpoint of design, we're trying to make things smaller. We're trying to get the wall thickness and the material to be lighter. And we're trying to educate the customers into those different materials. It's a hard push because we're just a consultant that can make recommendations. We're not the corporate leaders that can then demand that these changes take place. So we're kind of stepping on delicate waters or delicate glass, but we feel it's our responsibility and duty to make that education.
I was gonna have a very similar answer to that because, as we were looking at that, the design to launch, I guess, graph the life cycle of a product, there's a lot of steps on there, and all those steps, they require their own expertise, and they're all places to implement sustainable practices. That's a lot for any individual or even, individual companies to be experts in all those aspects. So, especially for us coming as consultants, being kind of generalists and being able to speak the language, be able to talk with experts and have a conversation with people that know more than us so that we can pass that on to other people that know less than us. So it's not necessarily us having, all the hard data. We just know the thought process that you need to have in order to make those changes.
And if I can throw my project manager hat on for a second, what I would say is, based on Lucas's presentation this morning, if you take 2 years to design the most beautifully sustainable product and then you airship it from China, have you really hit your goals? So I think there's a big takeaway for all of us about proper planning can really help a lot. And as consumers, how do we make sure that our forecasts are coming in properly so that we can help reduce the carbon footprint of that product coming into our own plant? And that sounds like maybe even more impactful than making a recyclable product. Although I love the idea of mushroom-based packaging and all these other big trends that are coming out. We should talk to our supply chain friends about making sure the forecasts are in place.
Agree.
Yeah, one additional thought on that. In the industrial space, everyone has a customer, everyone has a supplier, right? And increasingly, we're seeing in our business, our customers are being very specific in their ESG goals, flowing down to their suppliers. And so, to address the question of, how does an engineer or designer get started, listen to what your customer is specifically asking for, because in a lot of cases, they're getting very granular in their requirements in terms of embodied carbon, in terms of ethical employment practices. Are you sourcing materials from conflict regions? I mean, it's very expansive. And, and again, I think this is a good thing because there's a shared responsibility between customer, producer, supplier. It's that entire ecosystem as well. And so at least in our business, we're getting very clear messages from our customers that this is what we expect of you. And it's not just all about price, delivery, quality. These are the other things we expect from you. And by the way, we're going to be grading you on these on a regular basis. And that's a very strong motivation for taking action, in my opinion. If your customer's asking for it, you'd be foolish not to listen.
Absolutely.
Walmart had started that years ago where they had a checklist for all their vendors. And if they didn't meet the checklist, they were not going to be considered a vendor. And as a designer, I thought that was brilliant that Walmart was making and taking a stand on it. And I kind of see the trickle effect that's been happening where that same ideology is going to other industries, just like what you're talking about. And again, as designers, we're conscious of it. We're pushing for better materials and better solutions and smaller products, et cetera. And I think it's working. Little by little, I think that it's working.
Wonderful. Well, we've reached the end of our audience questions. Please feel free to drop any more in the chat that you might have. Any closing remarks? Anything you'd like to leave the audience with? One lasting impression? Education.
Education, yes. I think it's a really good thing that we're all doing and talking about. It starts with conversation and then really about getting it implemented and follow through. It's got me very excited to talk to our customers more about their ESG and what they're doing to really get an understanding for the impact that collectively we can make as designers and manufacturers, retailers, marketing. How do we do a better job at this? I do believe that the youth today is different than it was back in the 60s and 70s, where they're very conscious of the environment and they are looking forward and they are looking at companies that have the same values. And so if you don't change and listen to your customers, you're not going to be around.
Absolutely. And if anyone in the audience wants to partner with Beyond Design on a more sustainable product, where can they find you?
BeyondDesign.com. We're located in Chicago, Illinois.
Absolutely.
Thank you.
Thank you both for joining our panel. Thank you, Vivek, for joining the panel. Thank you to our entire audience for joining us. We really appreciate you spending the morning with us. We are continuing again tomorrow with Industrial Ethernet Week. We'll be back tomorrow, 9 a.m. U.S. Central Time. And the day 2 topic, simplification and ease of installation in the industrial Ethernet environment. Thanks again for joining, and we'll see you tomorrow.